Oh, Jason's here. Perfect. Jason, Sadie is here. Janessa isn't here. Kyle is here. Perfect. And Cindy is here. Okay. We're just waiting on Tyler and our other friend. Thank you for everybody that was putting questions in the chat appropriately. Chat needs to be used appropriately. Please and thank you. Let's take a look at our activity for today. Please open up the slideshow. We are getting started with our warm-up for today, which is, I just want to keep this open here, okay? So we're looking at this guy here. I'm gonna turn the light. Are we okay with it off? Okay. We're looking at graphing linear inequalities in two variables, part 2, okay? So it's like when you're on TikTok and they have like those multiple videos that's like part 2. I have recently gotten on TikTok, that's why I have brought it up. I don't make them, I just watch them. So don't be like, where's Mr. May? She's not on it. Here we go. Let's take a look at this warm-up for today. So our warm-up for today, we are talking about a homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod, which is like they grow grass and then they cut it up and it's like a little sheet and you put it down like a carpet. A grass sod and or flower beds on other parts. Grass sod costs $2 per square foot and flower bed installations cost $12 per square foot. Her budget for the total budget for the project is $3,000, okay? So what we're going to do first is I want you to write an equation, not an inequality, an equation that represents the square feet of grass sod X in the square feet of flower beds Y that she could afford if she uses her entire budget. So the reason we're writing an equation is because she's not spending less than up to $3,000. She's spending exactly $3,000. That's number 1. And then on number 2, you're going to graph that equation. Okay? It's going to be a standard form equation. So think about how do we graph standard form equations? 2 ways. Okay? So I want you to take 2 minutes. Actually, I'm going to give you, let's see. Yeah, I'm going to give you 3 minutes right now to do this, and then we're going to discuss before we have Spanish. Nice job, Gabe. So then start to graph it for yourself. So use, obviously, these points over here to plot some points. And you can use the line to do your line. And then if you need to put text boxes for your work to calculate anything, you can do those in the margins like I usually do. Nice job, Gabe, Kyle, and Peyton. Yes, that's so good. Ladies and gentlemen, super impressive. Good job, guys. Ava, I sent you a message, bud. Make sure you respond to that, please. Taking another 25, guys. You're doing great. Dennis and Tyler are here. Wonderful. Okay. So thank you for making it today, Janess and Tyler. I didn't get a chance to welcome you guys in. So let's take a look at first writing our equation. So if we were writing an equation this time, we're not talking about inequality because we're spending exactly $3,000. She's got the money, she's got to spend it. It's like a grant, you got to spend it all. What are we thinking about for an equation here? Abby Wasta, what were you thinking?
I said 3,000 equals 2x plus 12y.
Equals 2x plus 12y. Once again, this was a pretty straightforward equation, right? Because we're talking about x. We already, it identified what our variables were already. We just had to match those numbers up. And we're saying it's equal to because we're spending every single dollar of it. Spend it. Spend it if you got it. I mean, no. I take that back. That's not a good way to live your life. If you have to spend it, then spend it. If you don't have to spend it, save it. Or spend some. I don't know. Okay. Now we use the graph. This is sort of your choose your own adventure piece. Okay? So we have to graph the equation. 3,000 is equal to 2x plus 12y. Okay? This is a standard form equation. So there's two ways that you can graph this dude. What's one of the ways that we can graph it? Go ahead, Max.
What I did was I plugged in 0 for like x and y for like one time. Like one time I did 0 for x and another time I did 0 for y.
That's fine. That's called finding your intercepts or calculating your intercepts. Okay? And we can calculate our intercepts, right? And intercepts are counter what? What do I like to say? That big word, counterintuitive, right? Because you're looking for your x-intercept, so you plug 0 in for the y. Very good. So you take your equation here. We say 3,000 is equal to, we're finding our x, 2x. Okay? So then what's our x going to be here? I mean, yeah, what would our x be here? 1,500. So divide by 2, divide by 2. On this axis down here, 1,500 would be down here. Okay, finding our y. I just need 2 more seconds before you go to Spanish. Plugging in 0 for your y. X. 3,000 is equal to 12y. Divide by 12. What did we get when we divided by 12? 250. Very good. You would have your second point here. You could move, I would say move these points on here and then grab your line and connect them. This was on here to teach you and to reinforce this concept of calculating intercepts for standard form equations. Yes, you can convert it to y equals form. It's not always going to be the nicest though, because most of the time you're going to get stuck with fractions. And fractions are a little bit stinky. Because you have to sometimes you try to simplify them and you mess it up and blah, 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 blah. So my suggestion, do it this way, okay? So we're going to come back we're going to answer these questions when we come back from Spanish. My friends that are going to Spanish, she is here today. So please gather your belongings. People at home that are going to Spanish, you can move out into like her Zoom and then come back at our time that's posted in the classroom. Have a good time, guys. Friends that are here, I need you to log into Alex for me, please. We've got to finish up that time today. Get a good chunk of it done.
Does taking like a knowledge checks count towards the time because it's
yes.
Okay.
Knowledge checks do count. Yes. So I have. It should be. I'll send you the link.
She has one in her Google Classroom.
Oh, okay. Perfect. Yeah, go ahead. She might not call you down now though, because she's in another meeting. Like she's in another one, but she'll schedule something with you maybe today on Tuesday. Hey, Janessa. Hey, Junior. Hey, John. Hey, Kyle. Hey, Nassim. Hi. Hey, Sadie. Tyler. If you wouldn't mind jumping into Jello, Tyler. If you wouldn't mind jumping into Alex, that would be pretty cool.
Please excuse the interruption. Officer Gata, please call 4835. Officer Gata, 4835.
Wow, that was pretty high energy. I'm going to pause our recording. Need to be a responsible student and see that if you have Alex time, you're going to need to put time in at home outside of class to get that done. Because you took that responsibility of taking an extra class, you need to be responsible and get that time done. I have quite a few friends that still need to finish up their Alex time, so please make sure that you do that by midnight on Sunday, okay? So let's go back to this sort of situation where we were talking about this woman had some money, $3,000, to redo her yard, right? So she's gonna put some either grass down, some sod down, or some flower beds. Each one of those has a price for it per square foot. If we look back at that graph we created this graph of the situation in the equation by calculating our intercepts. When you're given a standard form equation, you have that flexibility of either converting it to y equals or calculating your y intercepts. Some cases it's going to be easier to convert it to y. Some cases it's going to be easier to convert it or calculate your y intercepts. You need to be flexible in your math thinking and make a decision based on the story. This story, I said we should do intercepts because we have small numbers and they went nicely into those values. I don't know who Adriana is, so I'm not letting that person know. Oh, who was it? Do you know who it is?
No, but she was in the film.
Was it Ava? I feel like it was Ava. I feel like it's definitely Ava. Hey, Ava. Ava, is that you that just came in? Let me know in the chat, Adriana. Okay, perfect. I just wanted to make sure. I was like, I'm not letting that person in. And they're like, no, that's definitely somebody from Spanish. Okay, so I will let everybody know that you are Adriana. I guess you're Adriana now. That's so weird. Okay. In this situation, what is a point that falls on our equation line? A point that falls on our equation line, what does it represent? Max.
The amount of square feet of flower beds and grass sods that cost $3,000.
Very good. That costs exactly $3,000. If that point falls on the line, it's a combination of grass, sod, and flowers that adds up to a total of $3,000. Very good, Max, on that one. Fantastic. Now, what does the vertical intercept represent in the context of the story? Looking at the label on our graph, our vertical intercept represents what? And? Very good. So the square feet of the flower beds that you can buy if what?
If you only buy flower beds.
Very good. It's that vertical intercept represents the amount of flower bed that you could put in, square feet, if you only put in flower beds, no grass. Good. Then that third question here asks us, what does that horizontal or x-intercept represent in this story? What do we think? So if the y-intercept or the vertical intercept represented how many square feet you could buy of flowers if you only bought flowers, what would that horizontal intercept represent? How much? Very good. Nice job, Peyton. How much grass or sod, if you want to use that word sod, how much sod you could buy if you only bought sod and no flowers? And it would be 1,500 square feet. Awesome job there, Peyton, on that one. Thank you for putting that one in the chat. Nice job, Kyle, as well. Fantastic. Okay. So our learning targets for today. Okay. So we're given a two variable inequality that represents a situation. I can interpret points on the coordinate plane and decide if they are a solution to the inequality. So right now we're talking about an equation. Now we're going to take that equation, we're going to switch up like the story a little bit, because before she had to spend exactly $3,000, we're going to change that story up and we're going to create an inequality. We're going to decide if we find a coordinate point, does it make sense in the context of that story? So we're going to be talking about, when we're talking about sort of where are we going to shade, that's where this is coming into context, like in the context of the story. We're bringing the context in to when we decide on where we're going to shade, okay? We're going to find a solution to a two variable inequality by using a graph of a related two variable equation. So we're going to take an equation line and we're going to use that idea, the concept of the related inequality, which is the same just with the symbol. And we're going to say, is it a solution, yes or no? And we're going to write inequalities to describe the constraints in the situation. We've been doing that for 4 or 5 days. That one shouldn't be too bad for us. Okay. So if we're looking and thinking about that homeowner that was putting grass down or flower beds down, now she was thinking, she was like, I got a price. Now she's starting to rethink her idea a little bit. She's saying, so the homeowner from the warm-up is worried about the work needed to maintain grass, a grass lawn, or in flower beds. So she's now looking at some more low maintenance materials. She's like, it's beautiful, but it's a lot of work. I'm not at home. I can't water my grass. I can't water my grass in the summer. There's a water shortage. She lives in California. Let's say that. So now she's looking at some more low maintenance materials. Okay. She's considering artificial turf, which costs $15 per square foot to install, and gravel, which costs $3 per square foot. She may use a combination of the two materials in different parts of the yard. Her budget is still $3,000. So now we're taking that idea of her budget. She wanted to spend exactly $3,000 before. We're going to be looking at that same budget, but now we might be a little bit more flexible with that budget. Okay. So what we want to do with this scenario now is we're going to, this graph right here represents this new set of stories, like this new story. Okay. We're talking about gravel. We're talking about artificial turf. Okay. How many square feet you can buy of each, that would add up to your total of $3,000. Okay. So I put a larger picture of it on slide number 8. So we're not going to do anything with this slide, but we're going to refer back to it. Okay. So if we look first at slide number 9, on slide number 9, I added a slide on here, so we're looking at 8. So the graph on slide 8 represents some. I'm going to go like this. The graph on slide 8 represents some constraints in this situation. Okay, it represents the price of that she can pay for the sod or the turf or the gravel. Okay, so the graph shows the line going through point 500, comma 100. Okay, so the graph shows it going through 500, comma 100. In this situation, what does the point 500, comma 100 mean? In the context of the story, I want you to take 30 seconds right now to think about what is the point 500, comma 100 mean in the context? Write an equation that represents this line. And I want you to think about what does this solutions to the equation mean? I'm going to give you 2 working minutes right now to look at all 3 of these questions and start to use that graph on slide 8 to answer them. First, what does that point mean? Write an equation that represents that line. Looks like this, really. And what is the solutions that fall on that line mean in the context of the story? Okay? I want you to take 2 minutes right now. Nice job, Kyle Kelly. job on that equation, Kelly. No, did I start recording again? I don't think I did. Oh, I did. Perfect. I just want to make sure everybody made it back from Spanish. Awesome. Now we have another 44. You're doing great today. I'm so proud of you. Doing great. I know I moved. Here, I'm going to, Ava, I'm going to rename you just so that people don't get annoyed. The fact that you don't have your name the right way. Ava. There we go. So Ava, I just changed your, yes, nice job. Nice job. So I just renamed you, Ava. Don't be like, oh no, my name is wrong. Now you should be good. Okay, so here we go. Awesome job. I love how hard people are working today. You're showing me that effort you show me every other day of the week. I love it. Okay, so let's take a look at this. So if we look at that graph on slide number 8, that point 500 comma 100, what did it represent in the context of this story? Abby Wasta.
That she could match 500 square feet of gravel and 100 square feet of dirt for a total of $3,000.
500 square feet of gravel and 100 square feet of turf, which will equal $3,000. Good. Very, very good. You want to make sure that you are looking at the labels of your axes and you're putting them in the correct order. X comma Y, right? X-axis is gravel, 500 square feet of gravel, 100 square feet of astroturf. Okay, that's probably where people are mostly going to get caught up, is making sure they're in the right order. X comma Y, horizontal comma vertical, over comma up, if you will. Nice job. So that was question number 1 there. Now it says we have to write an equation for this new set of constraints, because we had that equation before of 2x plus 12y is equal to $3,000. Let's see what an equation. Oh, that's okay. So if we look at the equation that someone created, what would be the equation for this line? I want you to take it one step back. We're not using this point to create the equation. We're using the prices that they gave us on the previous slide. So, Max, what were you thinking the equation for this would be?
3x plus 15y equals 3,000.
Okay. Do we agree? Do we disagree? And why do you think that, Ian?
Because the gravel costs $3 per square foot, and then the artificial costs $18 per foot.
Very good.
Gravel is on the x-axis, artificial is on the y.
That was literally every you talked about everything that I was going to follow up and ask you questions on if you didn't say it. Very good. So he said the three X are connected because the gravel costs $3 per square foot, and we're saying the X is our X axis where we have our gravel, plus the $15 per square foot of turf, and we use this variable Y because we're on the Y axis here, and it's equal to that total budget of $3,000. That was amazing, Ian. Perfect. Last question we had to look at here was, what do the solutions to the equation mean? If we're thinking about it in the context of this story, so any solution that falls along this line, let me just erase and let me just put some points on here. So I have this solution here. I have this solution here, here, here. What do the solutions in general represent? Max.
An amount of gravel and artificial turf that costs exactly $3,000.
Very good. The amount of gravel and turf that cost exactly $3,000. And I'm going to underline and bold this word exactly. The difference, the main difference between an equation and an inequality is an equation is talking about in one exact value. An inequality is talking about a solution set or a range of values that will satisfy or make that inequality true. That is the main difference between an equation and an inequality. Equations have one solution. Inequalities have a solution set or a set of solutions that will make it true. Nice job on that one. Very good. And nice job on that, Gabe. I like that. Very good. Yes, that's a simpler way of putting it, Peyton. I love it. Okay. Very good on that one. Now we're going to look at B next, or so it's 10, and it's number 2. So now we're going to look at that graph. I'm going to switch back to it. I want to just read this first. The point 600, 200 is located to the right and above the line. So when I go back, we'll look at it. Does this combination of turf and gravel meet the homeowner's constraints? Explain your reasoning. Explain or show your reasoning. Then choose another point in the same region, so to the right and above the line, and check if that combination meets the homeowner's constraints. This one I'm going to give you 1 minute for, because this one is really a review of everything we've been talking about. So this one should be not super duper easy, but relatively easy for you guys, okay? So I'm going to flip back to that graph so you can look at it, but I want you to consider that point 600, 200. Is it going to be a combination that'll work? Tell me yes or no, why? Now, and then also choose another one in the same region. Tell me, will that one work as well? Take 1 minute for yourself now on that one, because that one's not too bad. Nice job, Kyle Kelly. I'm going to read that one out in a moment, okay? So with this new sort of set of constraints here, her budget is laxing a little bit. Sometimes she might want to spend, if she doesn't necessarily need to spend that total of $3,000. But she still has that upper budget of $3,000. Okay, let's take a look at this guy here. Oh no. That smells like popcorn. Let's take a look at Kyle's explanation for this guy here. So Kyle said that he said for number 1 that the point 600 comma 200 is not going to be a solution, not a possible combination because it goes over the budget. Okay? So he said that 600 comma 200 is not going to be a combination because it's going to go over the budget. How did you know it goes over the budget? What could you do? And do the multiplication. Plug it into that equation and solve it. You could say we have our 3x plus 15y is equal to 3,000. And we'll see, is it equal or is it greater than? So let's take a look at this 600. 3 times 600 plus 15 times 200. And we're going to get 1,800 plus 3,000. Nice catch there. Thank you on that. Is equal to 3,000. So this is 1,000 or 4,800. That is over the budget. It's not going to work. Nice job on that one. Good. Just wanted to prove it. So now, what was another point that you plugged in and that you thought was not going to be a solution? What were you thinking, Max?
700, 300.
700, 300. So you went over to 700, up to 300. Good. Wait, 300 is all the way up top. Oh, it's all the way, like up off the, this is up off the grid up here. Nice. Very good. Okay. What was another one? And?
I just bet that no other point would work because like you're doing it three where we don't like put the area solution.
Good. So you said anything above here wouldn't work? Very good. Because if you take any of those coordinate points and you plug them in, they're always going to be more than that. That was supposed to be an arrow. That does not look like an arrow. Anything in this region right here is not going to work. So you could have picked this one here, here, in this middle box, boom, 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 like anywhere. All of these would not work because they'd be over that budget. Good. So now let's think about this last sort of constraint here. We're going to look on slide number 11. Okay. Slide number 11. Now we're going to be looking at this point 200 comma 100, and we're going to be making a decision. Because like I said, this lady was like, okay, I have $3,000 I can spend, but I might not want to spend all of it this time. She made a decision. She said, maybe I don't want to spend all of my money. Maybe I want to invest some of it for later when I retire. So I want you to think about these last two questions here. The point on slide number 11, it says the point 200 comma 100 is located to the left and below the line. Does that combination of turf and gravel meet the homeowner's constraints? Explain or show your reasoning. Choose another point to this in the same region to the left and below the line and check if that combination meets the homeowner's constraints. Okay, so now I want you to look at 200 comma 100. Does it meet the homeowner's constraints? Yes or no? Why do you think that? Pick another one that falls in this region right here. Does it meet the homeowner's constraints? I'm gonna give you a minute and a half for that one. Nice job there, Kyle Kelly. Wait, is that close all the way in? You can close that all the way tomorrow. Okay. I just don't want it to be cold. Nice job, my friends at home. Please make sure you can throw some answers in the chat for me. Okay, we have another 30 seconds, guys. let's think about this point right here, 200, comma, 100. First of all, let's think about it with our new modified constraints. When I just modified at the beginning the constraints, but before it had to equal $300 or $3,000. Now we said it could add up to $300 or $3,000. So if we say it could add up to $3,000, does this point represent a combination that they could buy? Why do you think that, Max?
I think that because if you do 200 times 3, you get 600, and if you do 100 times 15, you get 2,100, and 2,100 is less than 3,000.
Very good. Times 15. 15, that's a 15. You would get 600 plus 1,500. And it's going to be less than, or 1,200, or 2,100. You got this, kiddo. 2,100. And that is less than our budget of $3,000. Very good. So if we sort of loosen our constraints a little bit, and we say that now it can be up to $300 or $3,000, this guy would work. I'm going to throw in an extra little trickster question before we go on to question number 2. What if I had stuck to my original constraints of it has to be $3,000? What would you say about this guy then that time? Abby Wastow. Very good. And like we just said, if we're talking about an equation where it needs to be equal, the solutions only fall on that equation line. Anything that falls above or below are not going to work. Where we talk about above or below is when we start to think about up to $3,000, at least $3,000. Okay? Nice job. So then if you chose another point, what was another point that you chose under this line? That fell under, to the below and to the right of this, or to the left of this line. What was one you chose, Max?
0,
0, 0. Good. So she's like, yeah, I don't want to do it anymore. No more. 0, 0. Good. We would say that would be a possible combination. I mean, it wouldn't be logical, but it would be a possible combination. Good. So very good. And all these points that fall below this line, once we throw that constraint in, are going to be considered possible combinations. Very good. And I'm not going to move on to the next activity. So before we finish for today, this is a trick, not a trickster, but it's like an extra question. What if, so like if I extend this guy here, I'm going to go like this. What if I have this point right here where it's like, so maybe, let's say, for example, I extend my line and it hits at this 250. And it hits maybe at like -2. I don't know exactly where it's going to hit 250, but I'm just coming up with a point. If we're talking about logically in the context of this story, could this be a logical coordinate?
No,
Why do you think that?
because that means that she bought 250 square feet of artificial turf and she sold 2 feet of gravel.
Exactly. Like Gabe says, it doesn't make sense. So we always want to think about two things. Does it meet the constraints as like an equation or as an inequality? Then you want to think about logically, if we're dealing with a word problem, does it make sense? Okay. So ladies and gentlemen, you guys did phenomenal today. Awesome, awesome work. Your afternoon or your homework for this evening, you don't have to do anything on these other slides here. What you're doing for homework this evening is making sure you get your 60 minutes done. Okay, of Alex. Okay. Oh, I'm going. Yes.